All right, so let's talk about the end behavior of the polynomial functions. So polynomial functions can be graphed, right? You guys know that. Um, so we need to figure out what they look like, because before this we found how to find the zeros of the functions, but we don't know which way it curves and how to sketch that out, really. We're going to talk about that today. But first, let's figure out what is a polynomial function. Okay, so the definition of a polynomial function is of this form. So you have like numbers in front of x, and your x's have exponents. Okay, but um, the constraints are that your coefficients have to be real numbers, so they can't be imaginary, and your exponents have to be whole positive numbers. So, for example, I have 5x to the third power minus 2x. Now, this is a polynomial function, right? So you have to see, look, check these numbers. Are they real numbers? Yes. 5 and negative 2 are real numbers. Check the exponents. What's the exponent here? It's actually a 1, right? So are these whole real numbers or whole positive integers? Yes. Okay, so that is a polynomial. What if you have something like 5x squared plus 2x to the 1/2? Okay, is this a polynomial function? Look at this 5 and this positive 2. Are they real numbers? Yes. Look at the exponent. Are these integers? Are they whole numbers? No. So just because of that 1/2, it means that this is not a polynomial function, right? And that can be written as something like this: 5x squared plus 2 radical x. That is also not a polynomial function, because radical means it's an exponent to a fraction, right? This is, in this case, 1/2. So it's not a polynomial function. You have 5x to the third power minus x over 2. Okay, is this a polynomial function? Let's look at the 5 here. And what is the number in front of this x? What is the number in front of this x here? What it is, you have to understand that x over 2 is actually, you can rewrite that function as negative 1/2 x. So you look at this number here and the number here. Are they real numbers? Yes. Okay. They can be fractions. They can be negatives, but they have to be real numbers. So these numbers are real, and you look at the exponent here and the exponent here. Are these integers, positive integers? Yes, they are. So this is a polynomial function. Okay, so make sure you know the distinctions. The exponents have to be positive whole numbers, and the coefficients, the number in front, have to be real numbers. The coefficients can be fractions. The exponents cannot. All right, so let's go on and learn about the end behavior. So the end behavior of a function depends on two things. So the first thing is going to be the order, and the second thing is the leading coefficient. All right, so let's take a look at 3 x to the 5th minus 2 x to the 4th plus 1. Okay, so the order is the exponent on your x. That would be the biggest one. Okay, so the biggest exponent. So here, this x is to the 4th, this x is to the 5th. So the order is 5. And when the order is odd, it's different from when the order is even. Okay, when the order is odd, the two ends of the graph go in opposite direction. And when it's even, they go in the same direction. All right, now the leading coefficient is the coefficient in front of the x with the largest exponent. Okay, so you look at this x here and this x here. Which one has the largest exponent? This one. So you look at the number in front of it, and it's a 3. So the leading coefficient is 3. Now, it's different when it's positive, and it's different when it's negative. All right, positive means the right side points up. Negative means the right side points down. Okay, so these things here, you guys should take notes, write it down so you know what to do. So in this problem here, the end behavior is that because it's odd, one side has to point up and one side has to point down because it goes opposite direction. If it was even, they would both point in the same direction. Okay, now the leading coefficient is positive, so the right side points up. So on this side, it points up. Now because it's odd, they go in opposite directions, so this left side has to go in the opposite direction, which means down. All right, let's try another. I have f of x is equal to negative 2x squared plus 3x plus 5 minus 4x to the 4th power. Okay, so the order and the leading coefficient. So the order is the exponent on the largest one, right? The largest exponent. So this one is 1. This one is 0 because it doesn't have an x. This one is 2. This one is 4. Okay, the order is 4. So it's even. Even means they both go the same direction. Now the leading coefficient is the one in front of the largest exponent. So you know it's this one. So the leading coefficient is this negative 4 here. So negative 4. If it's negative, means the right side goes down. Okay, so I know this side goes down. Right side goes down. And because even means both sides go same direction, so the left side goes in the same direction. So it goes something like that. And your graph can be whatever in the middle. We don't know, but we know that right side goes down, left side goes down. Let's actually sketch something out. So I have f of x. Now it can be in this form, right? So x plus 3, x minus 5 squared, x plus 1. All right, so what is the order here? So the order is the largest exponent on x. But here, these are not multiplied out. These are factors. So you have to imagine what happens if you multiply them out. First of all, this is the first degree. So look at one factor. This is first degree. This one gives you a second degree. And this one gives you first degree. So the order total is 4. Okay. The leading coefficient is the one in front of the largest one. So if you take this biggest x, multiply to this biggest x, multiplies to this biggest x, it becomes a positive 1. All right, order is 4, means it's even, means they both point in the same direction. This one is positive, so the right side points up. That means the left side has to point up also because it's even. They both point in the same direction.